These notes are going to introduce you to linear equations and what makes them linear equations, and then the concept of intercept form, which you've actually done a little bit of without realizing that that's what it's called. So I'm going to give you the more formal language for it and definitions for it, and then we're going to see what you are already capable of doing and picking out from these notes. Right? So the first thing we want to talk about is the word linear equations on its own. Obviously, it's got the word linear in it, which basically clues you into what type it is. A linear equation is an equation whose graph is a line. So every one of these equations that you graph, their graph will be lines if it's a linear equation. Right. Now, there are three certain rules, if you wish, right, that qualify for an equation to be nonlinear or linear. Okay. Equations cannot have exponents, variables in the denominator, or variables multiplied together. If you see either one of these three things, or maybe a combination of any of the three, then you know that the equation that you are dealing with is not linear. Okay, if none of these exist, then the equation you've got is a linear equation. All right, so I'm going to give you some examples of linear equations versus nonlinear equations, right? So that you have an idea of what I'm talking about here. Right? If I give you the equation y equals 1 plus 4x, you always have to ask yourself, does it have exponents? Are there variables in the denominator, or are two letters being multiplied together? And the answer to all three of those questions is no, right? So that makes it linear. If I have y equals negative 0.7x, you ask yourself the same three questions. Does it have exponents? Is the variable in the denominator? Are two variables being multiplied together? And again, your answer is no. So anytime you can say no to all three of those questions, these are examples of your linear equations. When you go to graph those, you will get lines out of each one of those. Okay? But then if we take a look at the next set of examples, if I give you y equals x squared minus 4, okay, you ask yourself, does it have exponents? Yes, it does. As soon as you say yes, you know it's not linear, right? Same thing with this next one. If I give you y equals 2 over x plus 9, okay, you ask yourself, are there exponents? No. Are there variables in the denominator? Yes, right? So you said yes, that can't be linear, right? If you go to this last one, if I tell you xy equals negative 4, are there variables in the denominator? No. Are there exponents? No. Are variables being multiplied together? Yes. All three of these are what we call non-linear equations, which basically means that their graphs will not be lines. Right? So you will have to identify if an equation is linear or nonlinear based on knowing these three rules. Right? The next word we want to talk about is where we spend a lot of our time in the world of graphing lines, and that's intercept form. Right? Okay, and for intercept form, right, you can write it one of two ways. Right? It's written as y equals mx plus b, or if you wish to switch it around, you can write y equals b plus mx. Most of you are going to memorize it as y equals mx plus b because that's just how things flow, and that's the easy way of remembering it because that's almost what everybody calls it. Right? But you can switch it around and still be correct. And in this model, the b is the y-intercept, and m is the slope. We will devote a whole class period and more to the concept of slope, but for right now you need to know that the letter M is associated with the word slope and the letter B is associated with the word y-intercept. Okay? And for intercept form, there's some other names that they give it, right? You may also see this written in the directions as function form or slope-intercept form. All of it means exactly the same thing. So when they ask you to put the equation in function form, they're asking you to put it into y equals mx plus b. Right? So just realize that all of those mean the same thing. Right? The next word we want to talk about are the pieces of intercept form, because you need to understand a little bit more about them. Right? And the next one is the word y-intercept, right, which is the letter B in your formula. Okay, and you do need to memorize these formulas. Your formula sheet for the SOL test does not give them to you. There will be a lot more that we memorize up in the upcoming months, right? But for right now, start with the one that you're going to be using over and over again. The y-intercept, or your B value, is the location where the graph of the line crosses the y-axis. And the x value is always 0. If you remember from when we were writing equations from pictures, you always had to have a starting value. Your starting value is your y-intercept. So it's that value on the y-axis that your graph starts at. Okay? And then the last word that we will talk about is the words coefficient of x, and that's what we're calling it right now simply because we haven't gone into slope in any greater detail, right? So for right now we're just going to call it the coefficient of x, but you want to also realize that this is slope. Okay, and all of this is represented by the letter m. Right, so it has a couple different names, just like anything else in math has several names. You just need to know your synonyms for them. Right, and for the coefficient of x, in this case, what you need to realize is that it's the number multiplied by x. It will always be a number. If it's got an x, it's going to have a number. Okay, so the next examples that we're going to practice with, because right now that's all been definitions and understanding of terminology, but the next process that we're going to deal with something we did back in chapter 2, but you didn't realize you were doing it this way. All right, so the first thing that I'm going to have you do is to write each equation in intercept form. Then name the y-intercept and coefficient of x. So you've got two things to do here. You're going to write the equation in intercept form, right, if it's not already there, and then you're going to turn around and identify the y-intercept and the coefficient of x. Right, so for the first one, I'll start you off very basic. Y equals -6 plus 2/3 x. You'll notice it's already in intercept form. Intercept form just basically means that the y is completely by itself and the other side has been simplified. So anytime you're solving for the letter y, you're actually putting it in intercept form. Right? So this is already ready to go. We want to identify our m and our b from this problem. Okay? The b is always the number by itself. Right? So in this case, it'll be the -6. And the m is always the number connected to the x. Do not write the x, just the number connected to the x. So in this case, it would be the fraction 2/3. And that's all you're doing for this one because it was already ready to go. Now the next one is not ready to go. So if I have -9x plus y equals 14, the first thing you're going to have to do is put it into intercept form, right? And what that means is to get the y by itself. In other words, you might want to put a little note over here, solve for y, because it's exactly what you're doing. Once you get done solving for y, you're ready to pick out the other two pieces, right? So in order to get y by itself, I need to add 9x to both sides. So now I've got y equals 9x plus 14. Okay, and you'll notice your y is by itself, so you're ready to identify the two parts that you need, which are the m and the b. The m is connected to the x, so that would be the number 9. The b is the number by itself, which would be the positive 14. Okay. Okay, so we're going to practice some more of these because there are different variations. They do get a little harder and a little bit more complex looking. So I want to make sure that you're feeling comfortable with it before you come to class. Okay, so the next one is 4x minus 2y equals 15. Again, you want to solve for the y, so we're going to move the x first. Subtract your 4x to the other side. You have negative 2y equals negative 4x plus 15. Divide everybody by negative 2, and this is why it's important right now to divide everybody separately, because some things are going to simplify and others are not. Now clean it up so that you have a proper looking equation. Y equals positive 2x. 15 does not divide by negative 2, but a positive and a negative is going to turn into negative 15 over 2. Okay, and now that your y is by itself, you're ready to pick out your two pieces. The m is the number attached to the x, so that would be 2 in our case. The b is the number by itself, which in our case would be negative 15 over 2. Do not turn them into decimals, leave them as fractions. Because when you go to graph, we don't graph with decimals. All right. The last one of this type, and then I'll show you one other type of example that you will have to have some experience with, is when everything is on one side altogether and it equals 0. You're still doing the same thing. You're still getting the y by itself, but you got to move more than one thing this time. So start by adding the 12 over, and now you've got 3y minus 6x equals 12. Then move the 6x over. You're doing this in baby steps so that everything goes over on its own. 3y equals 6x plus 12, and now divide everybody by 3 so that it'll simplify and make an equation that's in the correct format. Okay, so that leaves me with y equals 2x plus 4. And the y is by itself, so I know I'm in good shape. I just need to list my m and my b. All right, my m is the coefficient of x, which would be the 2. My b is the number by itself, or the y-intercept, which would be positive 4. Okay. All right, the last example is going to still involve what we just showed you, but then it's going to have some more stuff to it. So for number 5, I'm going to have you complete the table, but in order to complete the table, you've got to do the equation work to get it in intercept form. It's not going to be ready to go. All right, so your equation that I'm going to have you use is 3x minus 4y equals 124. And yes, that's got some bigger numbers in it, but you'll be okay with it. Okay. The very first thing we want to do is to put it in intercept form first. All right, so we're going to take 3x minus 4y equals 124. Okay, and we're going to we're going to subtract 3x because we want the y to be there by itself. So now we've got negative 4y equals negative 3x plus 124. Okay, divide everybody by negative 4 so we can see what's going to simplify. Okay, and be careful, watch your signs. This is a negative 3 over a negative 4. It does not divide, but the two negatives do become positive, so this becomes positive 3/4 x. Then you have positive 124 divided by negative 4, which does make negative 31. So this is the equation that's going to help us complete the table. And the table you're going to be given on your sheets is going to have all the x values filled in, but it's going to have missing y values. Right? So if I give you this one with the values of 4, 12, negative 8, and negative 20, your job is to come up with the y values that were used in this equation to come up with using the x values to plug them in and come up with the y values that would fill in the missing parts of the table, right? And you can do this as easily as just replacing the same number throughout your equation, right? So now that I've got it y equals, I know my x's, so literally take and replace the x each time with the number. So I'm going to replace it with 4. I'm going to replace it with 12. I'm going to replace it with negative 8, and I'm going to replace it with negative 20. And the nice thing about these numbers are that the fraction is compatible to the numbers, so the fraction is going to go away. So you won't end up with any fractions in your answers. Right? So when we're going to do our work up here, 3/4 times 4, the 4's cross off. That leaves you with 3 minus 31. Right? And 3 minus 31 is going to give you negative 28. So you fill that in next to the 4. Come over to the next problem. 4 goes into 12 3 times, so cross the 12 out, make it a 3. Now multiply 3 times 3 and you get 9 minus 31. 9 minus 31 is going to give you negative 22. Go to the negative 8. Right? 4 goes into the 8 twice, but remember that's going to be a negative 2 because the negative sign's still there. 3 times negative 2 is negative 6. Negative 6 minus 31 is going to be negative 37. Come over here to the next one. 4 goes into 20 5 times, so that's a negative 5. 3 times negative 5 is negative 15. Negative 15 minus 31 is now going to give you negative 46. So in terms of answering the question, your answers are these four y values over here on the right-hand side. But the only way to get those, and the quickest way to get those, is by solving the equation for y first and then plugging those four x values in. Otherwise, the alternative to this would be to solve four separate two-step equations every single time. And while that's still going to give you the same answers, you're going to be taking an extra 5 to 10 minutes just to do that problem. All right, so it does make it faster and it makes it more accurate. Okay, so we're going to use this in class to help you see if you understand enough about intercept form to move on to the next part, and then we'll launch into that in order to graph.